session one more time. Okay, and the first thing we'll start with, before I go further, let me now go to here. Right. Empirical formula. Do you know, remember empirical formula? What's the meaning of empirical formula?
Simplest form.
Simplest form. Example, for example, if I have C3H C3H9 or no C3H6, then can we make this simpler? If this is the molecular formula,
to become C1 H3 or H2,
then it will become C1H2, and this is going to be called empirical formula. All right, empirical formula. Now, I want you to tell me what's the mass of the empirical formula here. What's the mass of this empirical formula? Go to your periodic table and tell me what's the total mass of the empirical formula. Mass of
14.
What?
14.
14.01 exactly. What's the mass of the molecular formula?
$42.
42. Is there any relation? Is there any relation?
Divided by 3.
If you divide this by 3, if you divide this, so what I'm trying to say, if you divide 42.03 divided by 14.01, this is equal to 3. So if I tell you that we have the empirical formula of if we have something with the empirical formula CH2 and we know the mass of the molecular formula is, so if you don't know this, but I'm telling you now, CH2 is empirical formula. And I know the mass of the compound, the molecular mass, I mean molecular mass of the compound is 54.04. This is the true mass here. All right. Then what is the compound? What should you do in this case? You should go and divide. First, find the mass of the empirical formula. What is it? We calculated already. 14.01. What's the mass of the molecular formula? 54.04. To find how much the what's the relation between them, divide 54.04 divided by 14.01. What's the answer?
Isn't it supposed to be 56?
56, is it? Let me see. Yes, it should be 56. Sorry. Yes, 56. I agree. It is 56. I agree. 56.04. So the relation is I divide the mass that I gave you. I already gave you this mass. Divide by the empirical formula, and I got 4. Then what's the molecular formula? It will be C4H8. Is this clear? I hope so. Good.
Yes,
Next.
yes.
Good. Next. If we have the masses of anything, then from the mass we can find the empirical formula. So what we are going to do here, we're going to find the empirical formula from the masses. We have here in this question 2 elements, N and O. The mass percent of this one is 30.45, and this one is 69.55. This is, if we assume that we have 100 gram, assume 100 gram, then you have 30.45 gram nitrogen and 69.55 gram oxygen. Okay? From this, can you find, you cannot relate things by gram, but you can relate things by mole. Can you find how many moles of nitrogen available in 30.45? What should you do?
Divided by the mass mole.
Of mass of what?
Mass mole.
Mass mole.
Atomic.
The atomic mass. Divide by the atomic mass for the molar mass, not atomic mass. Divide by the molar mass of nitrogen. What's the molar mass of nitrogen? What's the
14.
What?
14.
14. Divide 30 by 45. Add 30.45 divided by 14.01. Go ahead.
Uh, 2.17.
2.17. 2.17 mole. Good? Okay. How about oxygen?
10 molar mole.
What do you have?
4.35.
4.35. Exactly. Okay. And here, what's this? Mole. Then divide by the smallest number. Which one is the smaller? This one or this one? 2.17 is less. Divide by 2.17, both of them. What's the relation? One.
Multiply by 2.
This one is 2. Is this clear? So what do? I divide by smallest number. Clear? And this is 1 and this is 2. Clear? From this, when you divide by the smallest number, you have the ratio of the mole, then you can find the empirical formula. Simply, it is in this case NO2. So if I give you the percent of the component, then you can find the empirical formula by this method. So what are the steps? You put the masses of every element, put the mass of each element. This is the mass. What's the next step? Change to what?
Should change to mole.
2 moles. And then the third step?
Divide with the smallest number.
Divide by the smallest number, and you will get the ratio. And with the ratio that you did here, which is 1 and 2, you just put it under each one of these, as simple as that. Is this easy? Okay, and that's the solution. All right.
Victor, can you put the screen on the solution by steps? Yes. This one and the... Okay.
Next. Is this clear? Good.
Yes.
Yes,
Next.
clear.
Next. Combustion analysis. I want you to understand this combustion analysis. When I say combustion, always you should be able to write a chemical reaction. What do I mean by combustion? What's combustion?
احتراق.
Combustion
Burning the oxygen.
Changing chemical
reaction with what?
with chemical reaction or with
With oxygen.
With oxygen. With oxygen. What you're doing in your car, for example, you have combustion reaction. What's the combustion that we have in our cars? We are using carbon C8 H18 plus O2. That's what we're doing in our cars. We're burning benzene or gasoline with O2, which is oxygen, and this will give you what? Always. What?
CO.
CO2 plus H2O. That is the reaction of any organic compound or anything you burn with organic compound. That's the combustion reaction. You have to know this and keep it in your mind. Combustion reaction. Clear? Any question? Keep this in your mind. Whenever you burn any organic compound that contain carbon and hydrogen and maybe oxygen or nitrogen, what you're going to get is CO2 and H2O.
Doctor?
Yes.
But this is not balanced, and why we have 8 carbon and we have in the
balance it. It's not balanced.
And the product we have just 1 carbon. Where is it going? 7 carbon.
Multiply this by 8. Multiply this by 9. If you want to balance it, this reaction. What I'm trying to tell you that, and of course, and this by now it's balanced. But I'm not going to. Well, I'm not concentrating on balancing the equation now. I'm telling you that when you burn any organic compound, what you're going to get is O2, CO2 and H2O. And what do you mean by combustion? Combustion means reacting organic compound with oxygen to make CO2 and H2O. That's combustion reaction. Good? Okay, we do this in an instrument. This instrument, if we want to analyze, we want to do combustion analysis. So we take the sample, this is the sample, we burn it with oxygen, and then we collect all the water and all the CO2. So we collected here, collected all the water and all the oxygen. Then we will be able to know what's the mass of the water and the mass of the CO2. Is this clear? Now let's go back to our reaction. From where the carbon comes? All the carbon here comes from where? From here, right? And all the hydrogen here comes from here. So if I know how much water I have and how much carbon I have, then I can tell how much hydrogen I have and how much carbon I have, right? To do this, let me tell you this. Now, if I have CO2 and I want to know how much carbon in it, how much carbon in it? There is carbon and O2. Right?
Yes.
Okay. This means one molecule will give you one atom and two atom O. Okay? Okay, if we, of course, this will not happen, but I'm still trying to tell you that from where we got the information. This means instead of molecule, I can say 1 mole will give you also 1 mole of this one, of carbon, and 2 mole of O, oxygen. What's the mass of 1 mole of carbon? Carbon dioxide. What's the molar mass of carbon dioxide? Come on.
44.
Yes. Okay, 44.01. What's the mass of the carbon?
12.01.
12.01. And I don't want to care about the oxygen. I don't want to care about the oxygen at this time. Clear? This means if I have in my reaction, in this reaction, I have here, for example, let's assume that I have anything. Let's say we have X gram CO2. Then in this X gram CO2, how much carbon? Only carbon. I know that 44.01 will give me 12.01, so I should multiply this by 12.01 divided by 44.01, and this will give me how many gram, because this 44.01 gram CO2, and this is gram carbon. Gram CO2 will go with gram CO2, and they have gram carbon, and this will give me how much gram carbon I have in this reaction. Same thing with hydrogen. If I have H2O, and they know the amount of H2O, I know that H will give you what? H2O will give you 2H plus O, or one molecule H2O will give you 2 atom H and 1 atom H. Sorry, O. Okay, this means 1 mole H2O will give you 2 mole H and 1 mole O. Or I can say, what's the mass of water? (18.02 gram H2O will give you 2 times, because it's 2 mole, 2 times 1.008 gram hydrogen. And I don't care about the, this means if I have again Y gram H2O, how can I tell how much hydrogen in it? What should I do? I will write here.
Multiply by
The
2.
mass of hydrogen.
0.08 gram H divided by what?
Divide by 18.01.
18.02 gram H2O, and you have the amount of hydrogen. Is this clear? All right, very good. So I will give you a problem now in which I give you the amount, this X and Y. Keep this in mind. I will give you the X and the Y, and I want you to tell me how much carbon and how much hydrogen in it. Is this clear? Okay, let's solve this problem. combustion of 5.50 gram sample of benzene produced 18.59 gram CO2 and 3.81 gram H2O. All right, determine the empirical formula. From now I have 18.59 gram CO2. How can I find gram carbon? What does it equal to? How many gram carbon?
12.01.
18.59, whatever is given to me now, that's X. Now this one is the X that I showed you just a while ago, and this one is the Y in this reaction here. This is the X, and this is the Y. Clear? Now, if I have 18.59, I should, how can I find how many grams of carbon do I have? What should I do with this?
Multiply by number of moles.
Yes. I already did this for you. I changed it to mole and then to gram. You remember? I changed this mole and then gram, and then I have this one. So that's what I'm going to do. I'll do this one. So what should I do?
Change it to moles.
Multiply by 12.01.
Multiply by 12.01 gram carbon, divide by 44.01 gram CO2, and you have the answer. Can you tell what's the answer?
5.07.
Yes.
0.07.
07. Is this clear? Good. Can you tell me how many grams hydrogen? I have 3.81 gram H2O.
Multiply by 2.
Over 16.
2 multiply by
Multiply by
2 multiply by 1.008.
8 gram hydrogen. Write the whole everything, not only this one. Okay, divide by what?
18.02.
18.02 gram H2O. Gram H2O will go with gram H2O, and you have the answer in gram hydrogen. What is it? Give me an answer.
0.42.
0.42. Who else got the same answer?
Yes, it's the same.
Same. 0.42 gram hydrogen, and this is gram carbon. Good. Now, can you find the empirical formula? All right.
Doctor, I have a different answer.
What?
I have a different answer.
No, it should be correct. The answer is correct here.
Okay.
Okay. Okay. Before we go further, I want you to add this number with this number. Add them. What's the answer?
5.5 gram.
Exactly, which is here. Can you see what's here?
Yes.
This means the sample consists of what? Only carbon and hydrogen. Clear? Nothing else. If the sample here more than 5.5, this means there is another thing in the sample. Is this clear? If there is oxygen, there will be this number. For example, if there is oxygen, maybe this number will be 7 or 8, and then you have the total 5.5. This means if the total here is 5.50, but the mass here, for example, let's assume it was 7.89, for example. What does that mean? This means 5.0 is the carbon and the hydrogen, and the rest, which is 2.4, is what? Some figures, which is usually the oxygen, if there is oxygen. Is this clear? But in this time, in this example, in this example, it happened that the total is 5.50. This means the sample consists only of carbon and hydrogen. I will try to find the empirical formula. Can you do it? This is
C2H.
This is carbon, this is hydrogen. You should write first mass and then moles and then divide by smallest number. Okay, now what's the mass? What is the mass we have for the carbon? What is it?
5.07.
5.07.
5.07 gram. Hydrogen?
0.42.
0.42 gram hydrogen. Change it to mole. Yes, carbon.
12.01.
Now, what should you do with 12.01?
0.422.
0.422, yes. 0.422. How about this one?
How do we change it to moles, doctor?
What?
0.416.
Divide by molar mass from the periodic table. Keep the periodic table with you and divide 5.07 by the mass of carbon, which is 12.01. And this will give you the number of mole. And divide 0.42 by 1.008, which is the mass of hydrogen from the periodic table, and this will give you the mole. Which one is the smallest number?
The hydrogen.
No, they are both the same, approximately. All right, divide by the smallest number. What are you going to get? 1 to 1. So what's the empirical formula?
CH.
CH is the empirical formula. All right, CH.
Doctor, do you take the attendance?
I will take it now. No, I did not take it, but I will take it now. Okay, is this clear? So this is what's now the empirical formula. Good. If the mass of molecular formula is 78.12, 78.1, then what's the molecular formula? What should you do? First, find what's the mass of the empirical formula. What is it? This means the mass of carbon, which is 12.01 plus 1.008.
13.01.
13.01802. All right. 13.
Doctor, how we get 13.01?
It's the mass of carbon and hydrogen from your periodic table. Go to the periodic table, find what's the mass of carbon, what's the mass of hydrogen, add them together. All right. So if the molecular mass 78.4 or 0.5 even. Okay, then what's the mass? What's the molecular mass? You should take the 78.4, which I gave you this, divided by the empirical formula. What are you going to get?
6.
78.4 divided by 13.02. So what's the mass? What's the difference? Divide this number 78 by 13.02. What is it? 6. So the molecular formula is C6H6. Is this clear? And the empirical formula is CH. This is empirical, and this is molecular.
Doctor?
Yes.
78.4. From where did you get it?
I gave it to you. I'm giving it to you. I told you the mass. See, read this. I'm telling you this. The mass of the molecular formula is 78.4. This is the real mass. But what you got the empirical formula as CH, which is 13.2. I divide 78.4, divide by 13.02, and I got the molecular formula, which is C6H.
So the exam it will be given.
What again?
So it will be given in the exam.
Yes. The molecular formula, I will give you the molecular formula amount. All right? Okay. That's in the book. Just a second. Now, as you can see, this is the mass of carbon. This is the mass of hydrogen. When we add them together, they become 5.55. This means there is no oxygen. The compound, it has no oxygen in it. And that's why the mass is exactly for carbon and hydrogen only. If this mass is more than this mass is more than the actual mass, then there will be oxygen in the sample. Yes, you have a question?
Doctor, if we have in the final not CH, just we have like C2H, here we should do it 2C plus 1H and divide approximately the mass over this number.
Sure.
Right?
Sure. Okay, clear? Okay. Now, I will take the attendance now. The way I will take attendance, I want you to go to this. I want you now
Doctor, where can I find the absence and late?
How can I send you a message? Okay. I want you all go to this. I sent you by and the team. I sent you the connection. I want you to go to this link and write or press present now. Did you go there?
Where, Doctor?
In the message I sent you by on the Microsoft Teams. I sent you a message.
There is something error, Mr.
In the chat.
I don't have permission.
What again?
Could you send it in the
I
chat?
don't have permission.
This is the chat, isn't it?
Yeah, but we didn't has the access.
يا شباب اطلعوا وادخلوا على قناة الدكتور يطلع كأنك تدخل
يا أستاذ فتحت الرابط بس ما يدخلني على الصفحة، يقول لي ما عندك الإذن للدخول.
حتى أنا
ما يدخلنا يا دكتور. يحملك.
Okay, go ahead. Now, how about now?
نفس الشيء.
نفس الشيء؟
إيه.
دكتور وين الرابط؟
يقول something went wrong.
يقول عذرا ما
هذا هو شباب ارسلته في الشات.
Okay, try one more time.
Teacher, maybe press the share button.
Share.
Still same thing.
Can you see? I mean, I am in the page now. I want you to press anyone. I said here anyone, so it should be okay. Anyone with the link can respond.
Maybe the time is not correct.
Okay, let's try one more time. Try one more time. Can you log on now?
Yes.
Yes. Yes.
Then respond.
Oh, I can't.
Doctor, there is
attendance 1 and attendance 2. We should put present both of them.
Yeah, let's see today's trial. Let's put,
Doctor.
Yes.
How can I find my absence and late?
I did not do anything. This is the first time.
So for last lectures, there wasn't attendance.
Well, I have the record from Microsoft Teams, but I didn't do anything with it so far. Okay, did you finish responding?
Yes, done.
Yes.
Done. Okay, I will close it now. Okay.
Doctor?
Yes.
Didn't open for me.
رابط
me too. Didn't open.
شوف ارسلها عبد العزيز في الشات.
ايه شفته فين اعطيك الرابط الثاني الجديد.
شباب with the Chrome. Try open it with Chrome.
present 1 or 2?
2 of them.
Both.
All right. I'll stop it here. I hope everybody responded because I want to go back to the lecture. Okay. Very good. Okay, let's take this down. All right, and let's go back to our discussion. That's still there. Okay. Yes.
ما طلبني اسجل دخول، ما ادري اذا بيسجل الاي دي حقي او لا.
No, let's see what's the response today and we will see what to do next time. Anyway, all right. Now, when we have a chemical reaction, when we have any chemical reaction, for example, this chemical reaction, which is in this case, let's see. For example, I have 2CO plus O2, then this gives you CO2. If you have any chemical reaction, like this chemical reaction, then you should first balance this equation. Balance it very quickly. What should you do? This will be 2CO plus 1O2 to give you 2CO2. It's balanced. You should keep in mind, whenever you have a chemical reaction like this, then you can relate things by mole. You can say that 2 mole CO2 plus 1 mole O2 give you 2 mole CO2. So whatever number you have here, you should write it down and then say this is 1, keep the 1 as is, and write mole of this thing, mole of this one, mole of this one. Clear? Then the next step, sorry, this should be okay. Next, I want you to tell me what's the mass of 1 mole of CO. Quickly, from your periodic table.
13.02.
No, 12 is the carbon, and for oxygen is 16.
28.08.
Exactly, 28.1 gram CO. Clear? And this one,
32.
32 gram O2, and this one 2 times
88.
44.01 gram CO2. Is this clear? From where did I get these numbers?
Periodic table.
This is the molar mass from the periodic table. Clear? Good. Now, if I actually, in a reaction, I have only 10 grams CO, then how much CO2 I produce? I can do it directly. Look here, gram CO and gram CO2, I will put here 2 times 44.01 gram CO2 at the top, and I will write here 2 times 28.01 gram CO. Gram CO will go with gram CO, and you have the answer in gram CO2. Tell me now, this means if I have 10 grams of CO, how much CO2 I'll produce? Go ahead, tell me what's the answer.
$880.
What?
$15.71.
15.71. Let me see if everything is okay.
Yes, it's clear.
It's 15.71 exactly. You know how to do it now? So whenever I give you a chemical reaction, what's the first thing you should do? Put the number of moles of each component. So 2 mole of CO, 1 mole of O2, 2 mole of CO2. What's the next step? Change it to grams. Clear? How can you change it to gram? From periodic table. Use the periodic table all the time to find these masses. And then if I give you any one of them, then you should tell what's the amount of the other one. So if I have only 5 gram CO2, then how much CO do I need to make the reaction? See, what I have here is gram CO2. So I should multiply it by what? And divide by what?
Multiply by 2, multiplied by 28.01.
At the top, I should have 2 times 28.01, and then I should write gram CO. And at the bottom, 2 times 44.01 gram CO2. Get rid of this unit with this unit, and you have the answer.
3.18.
3.18.
18.
Don't forget to write gram CO. Okay, is this clear? How easy? Good. Let's solve this problem. You have this reaction. All right? This is the reaction now. Ammonia will react with CO2 to give you urea plus H2O. All right? This is the reaction. I read it for you. Now, calculate the amount of urea, which this is urea. I'll write U so that you remember. That is produced by complete reaction of 5.25 mole of ammonia. So if I have 5.25 mole ammonia NH3, then how many moles of urea I'm going to produce? Any answer?
What's the question, Doctor?
1 mole.
The question, one more time. If I give you a chemical reaction, look at this chemical reaction. What's the very first thing you should do? You should say that I have each 2 mole of this one react with what?
1 mole CO2.
1 mole CO2 and give you what?
1 mole.
1 mole, I will call it urea. This is called urea. And then
1 mole H2O.
1 mole H2O. From where you got this information?
From the number before.
From the chemical reaction. Clear?
Yes.
If I have 5.25 mole ammonia NH3, then how many mole urea I will produce?
2.63.
What should you write? Put the equation.
1/2.
1 what? Not
Mole
one.
of urea.
1 mole urea. Divided by what?
2 mole NH3.
2 mole NH3. I got this relation from the chemical reaction. Now, this will go with this, and I have the answer in mole urea. So what's the answer?
5.25 over 2.
Which is?
2.62.
2.6 or 7?
2.72.
2.72?
2.71.
2.75.
2.625.
2.63.
Yes.
2.625. So yes, you're absolutely right. 2. 2.625. Is this clear? That is if I want mole. If I want to do it gram, what should I do? I should calculate the amount of grams in each one of these. I hope this is clear. Good. All right. Let's do another problem. Nitrous oxide. Before we read even the question, what do you have in front of you? You have a chemical reaction, and it's already balanced. All right? What can you write under this equation?
1 mole.
1 mole
NH4NO3.
Ammonium
give you what?
1 mole
N2O
And
plus 2 more
water.
H2O.
H2O. Can you change this to gram?
Yes.
Go ahead and change it to grams. I want to put your periodic table, find what's the mass. What's the mass of this one?
Where is it?
What's the mass of NH4NO3? Get your calculator, periodic table and calculator, quickly.
$80 gram.
Is it 8? Yes. Yes, it is. 80.05 gram NH4NO3. Okay, how about N2O?
44.02.
44.02 gram NO2. Write the whole thing, not only, and water, of course, 2 times 18.02 gram H2O. See, I'm doing this before reading even the question. Is this clear?
Clear.
Now, I want to say nitrous oxide, commonly used as anesthetic in dentistry. What's anesthetic mean? مخدر الأسنان. Okay, dentistry, طب أسنان. Okay, we make it by this reaction. Now, calculate the mass of ammonium nitrate that must be heated in order to produce 10 grams of nitrous oxide. I want to produce 10 gram nitrous oxide, N2O. Then, how many grams of ammonium nitrate do I need?
0.05
by what?
over 44. 0.02.
What should I write? At the top and the bottom.
At the top 80.05.
80.05 gram. Write the whole thing. NH4NO3 divided by
44.02
4.02 gram N2O.
N2O.
Gram N2O will go with gram N2O. What's the answer?
18.1.
18.18. I need an answer. I don't know. Help me. What is it?
10.18.
18.18.
18.18 exactly. 18.18 gram NH4NO3. Now read the other one. Determine the corresponding mass of water produced by the reaction. How much water will be produced? What should I do? Again, the same reaction. This means how much, where should I start with? I still have 10 grams N2O. How much water will be produced also? Or will be at the same time with it? What should I do?
7.9.
What should I write at the bottom?
The whole mass minus.
44.
And then
No,
In the top,
the mass
2 multiplied by 18.082.
2 times 18.02 gram H2O. Gram NO2 will go with gram NO2 and you have the answer. What's the answer?
8.18.
8.18.
18.
1.8.
Let's hope so. I don't know if this is the correct. But see, how can you do, whenever you see a chemical reaction, you should think this is always.
Doctor?
And the answer is 18.18. Yes, absolutely right.
دكتور
Yes.
لما طلعنا اللي هو الماس الأول نقدر نقص على الهول ماس هذا بيطلع لي ماس اوف ووتر ولا ما يستوي؟
What do you mean?
الماس حق الووتر.
Yes.
احنا طلعنا ال 18.
Okay. If I have
هو 10.
Just a second. 18.18 gram NH4 NO3. Then how much water I'm going to produce? What should I do?
I think he mean why don't we just
no, do it from the chemical equation. Same thing. I have here gram NH2NO3. How can I find the amount of water? It's 2 times 18.01 02 gram H2O, and at the bottom, what should I write? What should I write at the bottom?
80.05.
80.05 gram NH2NO3. This gram NH2NO3 will go with this gram NH3. What's the answer? You will find the answer is 8 gram H2O, which is the same answer here. So whether you do it from this one or from this one, they are related. Everything is related.
Doctor.
Good. All right. Okay. Let's do one more time in the same area. Let's go back. Oh, and as I said, whenever you have a chemical reaction, like this chemical reaction, okay. Yes. Let's start with this chemical reaction. If you have this chemical reaction, concentrate on the chemical reaction only. Get your periodic table out. Okay? I want to, before we read the question, look at the chemical reaction. Did you look carefully at it? What's the first thing you should do?
Write the moles.
Write under each one of them 3 mole NaHCO3. And then here, what should I write? 1 mole H3C6H5O7. And what should I write here?
3 CO2.
CO2 here. 3 mole H2O. And here, 1 mole Na3C6H5O7. That's the very first thing. What's the next step?
It will all
Mass of everything. So I should multiply 3 times the mass of NaCO3, which is actually calculated very quickly, but it's actually 84.01 gram NaHCO3. When you do all of this, you will get to this slide. Can you see? What I did here, I start, this is a chemical reaction. I wrote under each one of them, what did I write?
3 mole.
Number of what?
The number of moles and the molar mass.
Then I change it to gram. Okay. Now, if I have 20 gram NaHCO3, then how many grams of Na3C6H5O7 I will produce? What should I do?
multiply 20 by 258 over 3 multiplied by 84.
Don't forget to put the whole unit. Okay, what you should at the top? 258.7 gram Na3C6H5O7, and at the bottom
3 multiplied by 84.01
multiplied by 84.01 gram, yes,
NaHCO3.
3 gram NaHCO3 will go with the gram of this one, and they have the answer. Is this clear? Do you know how to do this?
Yes.
Doctor?
Yes.
It will always be balanced?
No, you have to balance it.
Okay.
Sometimes it will be balanced, but sometimes if it's not balanced, make sure that it is balanced. If it's balanced, alhamdulillah, done. If it's not, then you cannot do anything before balancing it. Clear? Good. Let's assume that I want the answer. What's the answer here?
20.47.
48.
I need an answer.
20.48.
8 gram. Give me the whole name.
Of Na3 C6H5
C6H5
O7.
Good. Let's assume that I have also 20 gram H3 C6H5O7. Then how much of Na3, how much of this one I'm going to produce? Again, what should I write at the top? 258.07 gram Na3 C6H5O7, and what should I write at the bottom? 192.12 gram C6H5O7. This unit will go with this unit, and then you have the answer. I need the answer. Give me the answer.
26.86.
26.86. Who got the same answer?
I got the same answer.
Good. C6H5O7. Because I don't know what's the answer. Now, assume that we are in the lab. Okay? And I don't make this reaction. I put in my lab, I put 20 gram of this one, mix it with 20 gram of this one. Okay? And I calculated the amount of Na3C6, which is this one. How much I'm going to find? What will be the value for this one? I went to the lab and I mixed this 20 gram with 20 gram of this one. How much of this one I'm going to find?
47. Add the two results.
No.
20.48.
I'm going to get actually 20.48 gram. Why not this one? Why not the 26? See,
because we should take the lower one.
Let me see. When you make a reaction, you react 20 with the 20, and you're going to make this one. But you will make the one which is less. Why? Because this will finish. This one will finish. When you make this one, all of this will be gone. But this one, so we will not need this amount. We call in this case the 20 gram here, we call it limiting reactant. Why? Because if I have 20 gram, it need actually more than 20 gram of this one to make the reaction complete, but the 20 gram will produce only 20 gram of this one. The 20 gram of this one, if it react with a lot of this one, it will produce 26 gram of this one. So actually, in order to produce 20 gram of this one, from this amount we need more or less than the 20 gram of this one. We need only 16 gram. It will react with this one, but this will finish and we are not going to complete the reaction. Let me repeat this one more time. I'm trying to explain something called limiting reactant. Limiting reactant. What do I mean? We are mixing 20 gram of this one with this one to make this one. Let me give you some help here. If I have 20 gram NaHCO3, then how much of H3C6H5O7 do I need? What should I write? I will need 192.12 gram CH3C6H5O7 to divide by 3 times 84.01 gram NaHCO3. What's the answer? Give me an answer.
15.24.
15.24 gram of H3C6H5O7. This means 20 gram of this one will react only with 15.24 of this one and will make 20.48 gram of this one. How about I start to do 20? This means 20 minus 15.24, which is about 4.36 gram of H3C6H5O7 will be excess. This means we are not going to use it in the reaction. It will be extra. Is this clear? So in order for this reaction to be complete, this reaction 20 react completely with 15.24 and will make 20.48 gram. But the 4.36 of this compound will be excess. We are not going to use it in this reaction. Think about this very well, study it very well, and see you inshallah tomorrow in the exam only. There is no recitation tomorrow. We will meet only at night at 10 o'clock for the quiz, and see you inshallah Sunday. Don't forget on Saturday also, you have the common exam with other section on Saturday at 7 o'clock. All right, I wish you good luck, and the lecture is over for today, inshallah.
Doctor?
Yes.